Welcome to Hubbard Hall Seen Solved. I'm Tim Pennington, Editor-in-Chief of finishingandcoating.com. And today we're going to be chatting with wastewater treatment guru Robin Deal, product leader for AquaPure brand for Hubbard Hall.
This is Seen and Solved with host Tim Pennington, brought to you by Hubbard Hall. Better results, less chemistry.
Welcome, Robin, and where are you, if anywhere?
Hi, Tim. It's nice to see you again. I am in our Inman, South Carolina laboratory, where we do the majority of our binge testing for wastewater, as well as our pilot line testing for our other product lines.
So this is where everything gets done.
Everything gets done.
Right. Okay, great. And how many you all have 3 locations, correct? Is that right?
We have two manufacturing locations. Our headquarters and pilot first manufacturing facility is in Waterbury, Connecticut. Then we have our secondary manufacturing site here in Inman, South Carolina. We have a warehouse in Wilmington, Mass. And then we have 2 ship from warehouse points, one in Texas and one in Ohio.
Oh, okay. I wasn't aware of that. All right. Because I think the first time I met you, I walked into one of your talks, was it 10 years ago?
No, it was probably about seven years ago.
Right. You were nervous, but you did a great job. I think it was on the topic of wastewater, if I recall, correct?
Correct.
Yeah,
so
okay.
I got my start in wastewater treatment at a manufacturing plant, large hand tool manufacturing company. I moved into a wastewater operator position, and I took my licensing state exam through North Carolina to get a physical chemical wastewater operating certificate, and I've just progressed from there.
Wow. So how long have you been at Hubbard Hall now?
I've been at Hubbard Hall for a little over 8 years now. When the manufacturing facility I worked at shut down, we were using AquaPure products in our wastewater treatment, and our sales rep at the time was working with me to coordinate off-site shipment of Hubbard Hall products, such as what was going to other locations and what was going to be returned to Hubbard Hall. During the course of that, he asked me what my plans were once the plant was finally shut down, and I'd planned to go to work for my local city, POTW, and instead Hubbard Hall offered me a job coming to work for them as their technical expert out of the Southeast.
Gotcha. Well, some people want a career on Broadway, and that just wasn't in the cards for you. So I guess
yes,
it worked out very, very well. Matter of fact, our topic today is going to be removing metals from wastewater, which is what every finishing operation wants to do, tries to do. They don't always do. And when they don't, it becomes a huge issue for them. Correct?
That is correct.
And so, explain to me what would be a perfect, or what is the ideal wastewater treatment system look like from front to end? What is it, if you could draw it up the way you could magically do it on your Etch-a-Sketch, how would it look? What would it look like if people walked in?
So for a metal finishing or a plating shop, it's probably a little bit more complicated than a city or a POTW, in that we have metals that are very toxic to our environment and can kill the environment. In fact, in 2021, a facility in Indiana released cyanide-bearing wastewater to their local stream, and there was a rather large fish kill as a result of it.
Was that an accident, or was that?
Yes, it was an accident.
Okay.
Yeah. The pump dosing the cyanide destruction system failed on them, and it resulted in the accidental release. So depending on what your metal finishing operations look like, you may have to have a cyanide destruction system, and you may have to have a hexavalent chrome reduction system. And those 2 processes are done independently of a main wastewater treatment system. So cyanide destruction is accomplished through alkaline chlorination. That is a 2-stage process where you increase your pH to 10.5 or higher with hydroxide. Then you introduce a hypochlorite to a positive 550 or higher ORP or millivolt reading, and you allow the process to occur that will destroy the cyanide. Hexavalent chrome reduction works at the other end of the pH scale. You have to make sure your pH is at 2.5 or lower, and you introduce a reducing agent such as bisulfite till you see a positive 250 ORP reading. So those two systems work independently of the main wastewater system. When their processes are complete, they generally commingle back into the main wastewater stream.
Mm-hmm.
Does that make sense so far?
Yes. Okay. So that's what you're trying to basically almost make the water cleaner than what it is coming into the building, if you possibly can. Correct?
Right.
And I know a lot of shops will complain to me or say to me that they are sending water to wastewater. Their wastewater is cleaner than what it is that came into their building, which often is the case. But so let me ask you this: the big question is, the big challenge, I guess, with a lot of shops is removing it safely, and removing it efficiently. So let's talk about those three things. So what is used to remove the metals?
So when you remove metals, the most common process is a process called hydroxide precipitation, where you increase your pH with the sodium hydroxide, and then you introduce a flocculant or a polymer. Layman term, in wastewater, we call it snot because it's extremely slimy.
Ooh, wow. Okay.
And
that's actually a technical term?
That's a technical term in wastewater.
Who would have thought that?
And then you allow the solids to settle out, and your clear supernate goes out as your effluent. So that's the easiest process to do. Unfortunately, it's not always that easy with plating wastewater or some cleaning applications, because there's a thing called chelation and chelating agents that are introduced in the manufacturing side to assist those processes. So there's a very extensive list. There's numerous chelating agents out there in the world, but some of the strongest ones that we see in wastewater are citric acid, EDTA, pyrophosphate. Even though on a chemical engineering side or a chemical side, pyrophosphate is considered a sequestering agent, not a chelating agent. There's a difference between those two. But when it comes to wastewater, if you have pyrophosphate and it touches nickel, it will not release nickel. So that's why we call it a chelating agent. Gotcha. So when you have chelates present in your waste stream and you have metals present in your waste stream, the chelates lock onto the metals and they will not let them precipitate out. So then you introduce a coagulant, and coagulants can be iron, aluminum, calcium, or now we're seeing rare earth blends as well. Typical coagulants are just a metal salt. So you introduce those. Depending on the metal affinity to the base of the coagulant, you may find that if you have high chrome in your wastewater, you want an iron-based coagulant. Or if you have nickel in your wastewater, you want a aluminum-based coagulant. So you introduce your coagulant and you adjust your pH up to the desired hydroxide curve chart reading. Different metals have different optimal pHs. Then you introduce your flocculant. But again, some chelates, that's not all you need. So if you find that introducing a coagulant along with the pH adjustment doesn't work, you will have to use what's called a metal precipitant. And again, there's a whole list of those. The most common are DTC, sulfide, and thiocarbonates, or a blend of those. And how those work is,
go ahead, yeah.
When you introduce your coagulant and you adjust your pH up, you introduce the metal precipitant while you're watching your ORP or your millivolts. And when the pH drops, the ORP or millivolts drops 50 points, you've introduced enough of your metal precipitant.
Gotcha. Let me ask you, what you just said sounds perfect. But yet shops get in trouble. So where are they missing the point? Where are they having issues along that way that you're talking about? Is it having the proper chemistry, having the proper equipment, having it sized properly? And I'm assuming not everyone's trained as well as you are to do these types of things. So where do they have issues? Why? Where do you see it mostly that the issues spring up?
It's actually a combination. So wastewater in a lean manufacturing environment is probably last on the list of where money is spent. Wastewater treatment is never going to make a facility money. It may break even with things like sludge recycling, water recycling, things like that. But it's never going to make a plant money.
Right. It's not a coating application. Right. That's what they're focusing on, right?
And manufacturing plants are not in the wastewater treatment business. So it's kind of thought of last.
Well, they do get into it when the regulators come knocking at the door, that's when it seems to me they get real serious about it. That's when I get some calls, I get emails and questions, is they have somehow come in violation, right? They are not removing the metals to meet. And let's talk about that. You've got EPA guidelines, right? You've got local, the wastewater treatment plants have guidelines, right? You may even have a county or whatever it is. So there's a lot of moving points, right? And it can get confusing. And I think just a lot of people don't understand what some of these regulations and guidelines are about. Right?
So from an understanding level, you have two types of discharge permits that you could be issued. You can be issued an NPDES permit, which means you directly discharge back to the environment, or you can be issued a pre-treatment permit. So the NPDES permits, we don't see a lot of those in our industry, but they're written by the EPA. And they have really stringent limits because they're the last line of protection for the environment. Now the pre-treatment permits, and there's another thing called a sewage usage ordinance. They can be the same or they can be separate. And those are issued by local authorities such as your city or your county. In some cases, the city will issue the pre-treat permit and the county will issue the sewage usage ordinance, and they won't match up. I always tell my customers to err on the side of caution and go with the least amount that they can discharge. So what happens is when you're looking at your permit, even on your permit, you have a monthly average and a daily average, and they're different. So always err and try to target your wastewater to be less than whichever one is the least amount, because as long as you're meeting that, you will be good. Then when you look at your overall system, what I've seen is a lot of industries will introduce new processes, new production lines. Their production will ramp up tremendously.
Right.
But they don't.
And they're not paying attention to the wastewater treatment, correct?
Correct.
Load's not being taken into consideration.
Yeah. So when wastewater systems are overwhelmed, we have what's called pass-through. If you're putting more water in the system than the system was designed to handle, it's not going to be able to remove all the contaminants, and they're going to go out the door. So introducing new processes in manufacturing, you always need to take into account what your system is rated to handle and how you're going to help it handle these new influences. Then you also have to remember, if you go from flowing 15 gallons an hour to flowing 30 gallons an hour, your system is set up to handle that. So you're handling it fine, but your chemistry is set up to handle treating a certain amount of water. And if you don't upgrade your dosing to match the new flow, you're actually underdosing what the water flow is. So a prime example was, we had worked with a company a number of years ago that was originally flowing 15,000 gallons a day over the course of 16 hours. And they were flowing that amount because that's all that their wastewater system could handle using the chemistry that they were using at the time. So we worked with them. We got them compliant with their discharge permit because they were not compliant. They were releasing chrome and copper to the local city authority. So we got them compliant with that. And during the course of doing that, they were able to work with me to make some upgrades to their system so that it could flow more water in an hour. And in doing that, we doubled their flow from 15,000 gallons a day to 30,000 gallons a day. And by allowing them to do that, they were able to double their manufacturing processes.
Gotcha. Yeah. I mean, I hear a lot of facilities do that where they add a second shift. And I don't think they went out and added a second wastewater treatment system because, to run those and things like that. But let me ask you, we've talked about heavy metals, medical particles. What are those, and what are the requirements to get rid of those from the wastewater system?
So are you talking about things like chrome, nickel, zinc, cadmium, lead?
Yes, correct. Right.
So how you remove those, you have two options. The most common is hydroxide precipitation. Mm-hmm. There's another option chemically that's called sulfide precipitation. Mm-hmm. So you introduce a sulfide, such as sodium sulfide, to your waste stream at a much lower pH, and it works similar to hydroxide precipitation, in that you introduce the sulfide and you keep the pH at a lower level. Why we don't see that as much in our wastewater treatment industry is because sulfides smell really, really bad. And it will also damage the environment. Specifically, if you go below a 6.5 pH and sulfides are in the water, you're at risk of producing hydrogen sulfide gas, which kills people, and it's also extremely corrosive.
I'm sure that would be bad.
Yes. So that's the two chemical ways you can remove metals. You can also remove metals through things like ion exchange. Metal removal can also occur with membrane filtration, such as a nanofilter or a microfilter. You can remove metals. You can remove the water from the metals through evaporation, which dehydrates the metals, and now you're just left with a dried metal sludge that you have to dispose of, and you don't discharge water.
Gotcha. So how do these shops know? I mean, we're talking about a lot of different moving parts, flocculants and precipitants. How do they know if these are actually working effectively for them? Is it just by seeing the levels that they're sending out, or how do they actually know that they're using it and using it correctly?
So we always recommend binge testing, whether it's independently done by the operators, or you bring an expert in, such as myself or one of my team members. Binge testing gives us a snapshot. So we'll take 1,000 ml sample of your wastewater before anything is done to it, and we will treat it in a beaker and do everything that is happening in your wastewater system in that one beaker. And then we can test the supernate off of that beaker to see if we're removing the metals properly or if there's other contaminants, such as maybe you have oil and grease in your wastewater. Are we removing that? Maybe there's dye in your wastewater and your water's pink from an anodizing process, and the city doesn't want your pink water. Yeah. So binge testing is how you see the overall health of your wastewater system. It's how you determine if you're dosing your chemistry correctly. Then you scale that up. So if you look at a binge test, and a binge test shows that you need 1 mil per gallon of your coagulant, and you need your pH to go to 9, and you need 2 mils per gallon of your flocculant, then you go to your wastewater system itself and you check your feed rates on your pumps. Is your pump pumping at 1 mil per gallon of a flow rate of 20 gallons per minute?
Mm-hmm.
So then you should be pumping 20 mils per minute. So you check that and make sure that's what's happening. Then you look at your pH. Are your pH probes clean and properly calibrated and reading accurately? Is your pH control set to maintain that pH of 9? If that's correct, then you move down to your flocculant. Is your flocculant made up properly at the 0.2%? Is it dosing right? Are you maybe overdosing it, in which case you might see flock floating in your clarifier? Are you underdosing it, in which case you don't see flock at all? So everything you do in a bench test, you then correlate to your actual wastewater system and walk your wastewater system and make sure that what's happening is what's supposed to happen.
Gotcha. And let's close out with this. I like to kind of give people, some positive things to think about, right? What are 2 or 3 really good traits you've seen that shops do, or best practices, 2 or 3, to really keep their wastewater system in good shape, so that maybe they could think about adopting it? When you go in, you see a really nice system. What are 2 or 3 traits that they're doing? I mean, I'm assuming they have someone specifically hired to look at this. Are they doing regular routine maintenance? What are 2 or 3 things that you can tell people that you've seen other really good looking systems that make them work well?
So first is making sure you have someone dedicated to wastewater. And
how does that happen a lot or not? I mean, it doesn't seem like you see a lot of people. It's usually this person is this title / wastewater, correct? It doesn't always seem like that's their full-time gig, but it seems like it should be, right? But
in the most cases, it's not. Most cases, it's a maintenance guy or the maintenance department, or maybe it's the plating line manager. And their focus is on keeping the manufacturing running.
Right.
And the reason why is a lot of times wastewater operators look like they're not doing anything.
Right.
I'm going to be honest.
Right. They're not. They're just kind of monitoring and in case the fire, they need to put out a fire with that. So what you're saying is really these facilities need to have somebody who's really truly dedicated and takes it seriously.
Correct. Right. So when you have a dedicated wastewater operator, their whole job is ensuring that the water that leaves your facility, your effluent, meets every set guideline. The training that they receive is not just for wastewater treatment. They also receive first responder and spill response treatment training. So they know how to handle if your plating line and your hexavalent chrome spills and hits wastewater. They know what to do and how to correct that problem so you don't have a pass-through event. They receive maintenance training, so they know how to rebuild pumps, and how they receive plumbing training, so they know how to pipe properly and how pipes should flow and how to repair leaky pipes. They receive IT training, so they know how to handle the PLC or SCADA unit that your system may be operating under. And if 90% of the time they look like they're not really doing anything, you can trust and believe they are. They're going through a checklist in their head. They're listening to the pumps to make sure that they're pumping properly. because you can tell a difference when a pump doesn't work.
Right,
They're
right.
smelling the air to make sure that the air smells the way it normally does, because if there's a spill of ammonia on your
Definitely an odor. You can tell that.
you can definitely tell it in your wastewater.
Right.
And a best practice is to have an operator dedicated to wastewater, but give him a checklist for the wastewater system to check every hour, check to make sure the flock is forming, check to make sure the pH is right, check to make sure the chemicals are feeding right, that there's chemicals to last. And then you also give him another list of things to do, such as cleaning drums and storing them properly for disposal, helping move product around, things like
because
that.
if the line is running, if the system is running pretty good, there's not much he or her are doing, correct?
Correct.
Because I've always felt that it should be the wastewater treatment person, that should be their number one job, and then they have a sub job to do something else. And if everything's going well and they're doing their job, then everything's running smoothly. So so we talked about that of having somebody who's a little bit more dedicated, like you said, which I think a lot of shops don't particularly have. But what would be one more that you could try? Is it investing in equipment, investing in technology? What is it that you're saying with that?
One more thing that I see shops do, I'm going to actually give you two.
Okay.
One is definitely working with a chemical supply partner who fully understands wastewater, who's not just trying to sell you a commodity chemical at 10 cents a pound that's going to produce 50 cubic yards of sludge a month that you have to dispose of. You want to work with a partner who's going to help you reduce your sludge, reduce your chemical usage, and help you improve your wastewater processes. And you have to trust them enough that you believe them when they say you need a new tank, or you need a larger clarifier, or you need to expand your filter press. So working with a partner like that is always good. And then I'm going to say the last thing is understanding why wastewater works with your manufacturing processes. And what I mean by that is, we had one customer in 8 years that I've been with Hubbard Hall. I've only seen one customer do this, but I really wish all of our customers would. This customer knew that for every gallon of wastewater that left his plant, he produced 10 finished parts. Oh. And off of those 10 finished parts, after he paid all the bills for manufacturing them and what he paid to treat that wastewater to leave his plant, he knew how much profit he made.
Right. Well, yeah, most people I've never heard measure that.
Right. And so how much wet water do you need to produce a part?
Right.
And what does that ultimately cost you?
Right. Yeah. Like I said, it is, I think you're right. It's really knowing your numbers, knowing what's going into your system, knowing, who's running it, how it's being run, and getting those reports. So anyway, by golly, Robin, this is called Seen and Solved. And I think we solved an issue today. Don't you believe that? I believe so. Mission accomplished with that. So, well, listen, thank you very much. We will talk to you again soon. And again, we'll probably be talking about wastewater and treatment. So thanks for joining me.
Thank you for talking with me today, Tim.
Seen and Solved is brought to you by Hubbard Hall. Better results, less chemistry. For more podcasts, go to hubbardhall.com or wherever you get your podcasts.